So we made this multipurpose IoT tracker version 2 project that will help you to track the real-time location of anyone or any vehicle along with the timestamps, can help you to spy someone's conversation secretly with its built-in microphone, and with the press of the SOS button you can send your current location and make the call immediately to your loved ones in case of some emergency. So this is the upgraded version of our previous multipurpose IoT tracker project which we made back in 2022, and you all people kind of loved that project and the response was so amazing that we ended up selling hundreds of units both nationally and internationally. And now we came up with the updated version 2 of this project, and in this video I'll let you know what's new in it, how we made it and how it works. And in the end, if you love this project, well, you can get one for yourself from our website. I'll be sharing more details about it in this video, so just keep watching it till the end and let's get started. This video is sponsored by LTM, which is a PCB designer based software company. Now LTM is not just another PCB designing software, rather it's a world-class and award-winning PCB designing tool that has some features like advanced interactive routing with auto-completion, any angle routing, bus routing, phase and length tuning, follow me more and much more, which makes it an ideal choice for PCB designing by a lot of companies. Along with this, they do also have LTM 365 that not just covers the PCB designing part but also helps with design sharing via web, sharing designs to mechanical team for product design, centralized cloud storage and a lot more. And along with all this, they do have a very useful search engine made just for electronic components called as Octopart. Using Octopart, you can search for any components and you will be able to compare its price and availability around the globe. Not only that, you can also get the details about the components like its specifications and datasheet all at one single place. So LTM provides everything to make your production task a lot easier. So do try out all these services right now, as you'll be getting a free trial version by just clicking the link mentioned in the description. Happy making! Now let's start with the hardware part. So for making this project, we'll be using these all components, which are majority the surface mount components. Now here, this time we are using the A9G module rather than the complete development board, and also to reduce the price a bit, this time we are using the ESP32 room chip rather than the complete Xiao ESP32 C3 module. Then we make the complete schematic of this project, and now if I take you through some important parts, then here we have used a TP4056 as the battery charging circuit with over voltage protection. Then we use the microphone on board for listening to the audio conversation. Well, this microphone is way more sensitive and clear than the previous one which comes with the built-in A9G board. And now if I talk about the programming circuit, then here we are using the CH340 based auto programming circuit, but for the safer side we also provide the reset and boot button on the board. So that's the complete schematic, and we'll be providing the schematic in our GitHub repository, whose link is down in the description of this video. So after finalizing the schematic, we turned into the PCB file, and after that we gave the order of this PCB from JLC PCB. Now even you can try ordering your own custom PCB project from JLC PCB by following very simple steps. You just need to follow the Gerber file of the PCB project, select the color masking and just pay for your order. And here if you select the fastest delivery option, well, you may get the PCBs delivered within a week. And other than PCBs, JLC PCB also offers the SMT assembly service and the 3D printing service. So do check out all those services from the link mentioned in the description of this video. So here are those PCBs delivered us safely. Now let's move on to the complete soldering process. See, all the surface mount components are soldered on the PCB, and now one by one we'll also start soldering the DIP components, and in the end our final PCB looks like this. Now this time we also designed a 3D printed case for this project, and then we attach a printed sticker on it with all the labels and branding for this project. And that's the complete hardware part of the project. Now it's time to test it out. So this time we made 3 different codes to play with this project. So let's just test all of them one by one. So the first code is all about testing our multipurpose IoT tracker using the manual AT commands. So here is the code. So I have defined all the pins, like necessary pins for powering on the A9G board automatically. So in the previous version, we need to manually press the power button on the A9G board to power it up. But now the ESP32 board will take care of powering up the A9G board, and those are the pins. And here the SOS button is attached to the pin 22. Okay. After that, we are beginning the serial monitor. This is for our ESP32 board, and this is for the A9G board, which is connected to the 33 and 25 GPI of ESP32. Declaring pin as output, and this command is used for powering up the A9G board. Okay, so rather than pressing the manual button, we are providing the power to the GPI pin, or the power pin, you can say. Then here we are just using the multi-serial communication code, which is sending the data from one port and receiving from another port. Now to upload this code, first of all you need to connect the tracker using a Type-C cable with your computer and make sure the switch is in the on position. After that, here I'll select the right board, which is, you can select like do it ESP32 DevKit V1 as well. After that, I'll select the right COM port and I will hit the upload button. Now here we have already attached the auto programming circuit to automatically upload the code into ESP32 board. But in case it doesn't get uploaded, well, we do have the boot button on board. So you can press and hold the boot button and the code will definitely get uploaded. Okay, so the code is successfully uploaded. I'll open the serial monitor and let's just try typing the command AT to see if everything is working or not. Okay, so I got the response as okay, which means that ESP32 and A9G are successfully able to communicate with each other. Now I'll let you know a couple of more AT commands to test out each and everything. So next command is AT plus RST is equal to 1. Now this will reset the A9G board, which will make sure that all the parameters are set to the default state. Okay, so I'll type enter and it will manually reset the A9G board. Let's just wait for a couple of seconds. Okay, so after resetting, now let's just test whether the SIM card is detected or not. For that, I'll type as AT plus CPIN question mark. And as you can see, it says C pin ready, which means the SIM card is successfully detected. Now let's type out the next AT command to see the available networks here. For that, I'll type AT plus COPS is equal to question mark. And this command will definitely take a couple of seconds to get the data. So let's just wait for it. And here we got the data. So Vodafone network is the strongest network available here. That's because I'm using the VI SIM card. Now here, the A9G board only supports the 2G band. So make sure you use the SIM card who has the 2G bands available. For India, you can use VI and Airtel. So after testing the SIM card and its network, now let's test out the built-in microphone and speaker by calling to some other phone. Now before making the call, we need to do some configurations for the speaker. So yes, this time we also attach the speaker along with the microphone. So it's kind of a two-way communication. You can talk with this IoT tracker with the other person as well. So now for the configuration of the speaker, first we need to select the channel. So I'll type the AT command as AT plus SNFS is equal to 2. It will select the channel 2, and now to make the volume as maximum, the command is AT plus CLVL is equal to 8. Now 8 is the maximum volume, and now we are good to go to make a call. Okay, so now to make the call, the AT command is ATD, and then you have to type the mobile number along with the country code. So I'll type out my office number here, and in the end you have to put the semicolon, then press enter to make the call. Okay, it's ringing in the speaker.
Hello.
Hello?
Hello.
Am I audible?
Yeah, you're audible.
Okay, so I'm audible and I can also listen to the speaker. Let me just make the speaker connect to the bigger one, bigger microphone. Yeah, tell me how it's going.
It's wonderful.
How's the new tracker?
It's amazing.
And what do you think, how many orders will get?
Like 1,000.
Sorry?
1,000.
Okay, so hope for the best. And yeah, with this we successfully tested the microphone and the speaker as well. And now to cut down the phone, the AT command is AT plus CHUP. That is chup, right? And yeah, the call is disconnected. And with this we have successfully tested the microphone and the speaker, and now we are left with testing the GPS. And for that we need to move towards the Windows side. So let me change my position and we'll test the GPS as well. So now I am at the window location where I place the tracker outside to get the GPS signal. Okay, and now let's just try out the AT commands for GPS. So to turn on the GPS, the AT command is AT plus GPS is equal to 1. it will turn on the GPS, and now the A9G, like the tracker, is finding the satellite connectivity. And to get the location, the AT command is AT plus location is equal to 2. Okay, so right now it got the satellite connectivity. It may take some time in your case, but in my case, it find the network, it find the satellite connectivity, and here is the latitude and longitude data. And that's how we came to the conclusion that the GPS is also working. So this was the demo code which I'll be providing, and with this, you can test all the AT commands and test all the peripherals of this tracker. Now let's move on to the next code. So now the second code is kind of same as that we have used for the IoT tracker version 1, in which we used to send the SMS for getting the location, and also there was a feature of SOS button and stuff like that. So we are using that same code but with some modification and with some improvement. So let me show you that code, and in the end I'll show you the demo of that as well. Okay, so here is the code. First of all, the pin configurations, okay, then necessary variables, pretty common. Now here we need to type out the SOS number on which we need to send the SMS and make the call. After that, here you need to provide the APN name as well according to your network provider. Straight after that, here is the SOS time, means now you can change the time interval. So what we're doing is, when the button is pressed and hold for more than 5 seconds, then only the SOS action will be triggered. You can decrease the number of seconds, you can increase the number of seconds based upon your application. After that, necessary like serial communication, input output declaration. Now here what we did is, we are turning off the Wi-Fi and Bluetooth of ESP32 to save the power, because we don't require Wi-Fi and Bluetooth in the whole IoT tracker code, okay. Straight after that, we are waiting for 20 seconds for initialization of A9G, and then what we are doing is, here we have put a different kind of coding. So previously what we were doing is, we were just throwing the AT commands, and without waiting for the response, we were providing the next AT command and next and so on. But this time what we did is, we are sending the AT command, and until and unless we are not getting okay response of that command, we are not moving ahead. We are just trying that AT command, okay. So with this, we can be sure that each and every AT command is properly executed before providing the next AT command. So that kind of improvement we did in this coding. So we are checking the AT command here, we are turning on the GPS, then GPS low power, then we are initializing the sleep mode, and this all AT commands for SMS, and these all AT commands for speaker, okay. Now straight away moving on to the loop part. Then loop part may seem pretty much same, but there are little modifications. For example, earlier we need to send the send location in all capitals only, but now you can send it in all small and with first letter capital. So all the 3 SMS will be considered valid and will be getting the Google Maps link with the location. Then this feature is newly added here. So in this GPS tracker, we can check the battery voltage or battery percentage as well. You just need to type out the SMS called as battery question mark in all capitals, battery in all smalls, and battery with the first letter capitals with the question mark, and the A9G board will send the SMS for the battery percentage, which is really very cool to check out how much battery is left on our board, okay. Then other features are same, like as soon as the phone is ringing, it will automatically receive it. And after that, the SOS button feature is also provided, in which pressing and holding an SOS button for a particular amount of time will trigger the SOS condition, means send the current location and give the call to that number. So that was the code, like modified code for this new version. Now straight away I will select the right board and COM port and hit the upload button. Okay, so the code is successfully uploaded. Now open the serial monitor, and here now we need to wait for at least 20 seconds for all the initialization of A9G commands. Okay, so commands started executing one by one, and here I have added one more feature which I missed during the code explanation, and now let me tell you that feature. So yeah, here is that feature. So once all the commands are successfully executed, we will get an SMS on the SOS number saying that A9G ready. So what happens is, this is a battery powered project and you're not sure whether it is connected to the network, or if it is powered on successfully and everything is working or not. But with this SMS, you can be sure that your A9G is powered on, it's connected, and it's working fine, okay. So that's a feature we have added in the new version. Now let's just try out other features one by one. So let's just check out the battery, how much battery percentage is there in our like built-in battery. So I'll type battery question mark and click on the send button, and let's just wait for it. Okay, so the message is received here, and the received data is 100%. That means the battery is fully charged, and the response will be getting here as well. Great. So we got the SMS as 100, which means battery is 100% charged. Let's just test out the next command, which is send location. And now, as I said in the code, we can type out in different characters like capital and small. Okay, so I'll type out send location Oh, I've given the wrong command. It's not send location question mark. It was just send location. Let me just type out another SMS, send location without spaces. Okay. So I will click on the send button, and now let's just wait for the location data. And I have put the A9G board, the tracker board, outside the window for proper satellite connections. We received the latitude longitude data here, and now let's just wait for the SMS. Okay, we got the SMS with the Google Maps link, and if I click on the link and click on open, it gives me the exact location of my studio. So the GPS feature is also working fine. Now let's just test out the auto call receive feature. So I'll make call to this number. Okay, so as you can see, the call is received and it is interference happening. So I'll click on the hang up button. So we are successfully able to receive the call. Now let's just test out the SOS feature. So I'll press and hold the button for more than 5 seconds. It says calling in 5, 4, 3, 2 and 1. So SOS is triggered. Now it will send the SMS with the location along with the phone call. Let's just wait for it. So we received the SMS with the location, like the Google Maps link, and we got the call as well. So that was the SOS feature, which is also working completely fine here. So that's the SMS based firmware or the code which we have written for the version 2 improved version with a couple of added features like battery and what you can say A9G ready message at the startup. Now let me take you to the third code, which is about real-time location tracking. Let me show you that. So this third code was the main reason why I made the version 2 of this project. So majority of people who bought the version 1 of the project want a feature of real-time location tracking. So till now we are able to get the location, but only when we send the SMS. But what if we want to get the location at every particular time interval? Well, this code satisfies your requirement, plus it got way more features in it. And it is totally customizable. Like I have written an MQTT based code, like you can transfer the data via MQTT over internet via GSM network. I'm using the Adafruit MQTT broker here because it was available for free of course, but you can use any MQTT broker and you can even use your own MQTT broker deployed on your own cloud server. I'll be providing the example code for that in my GitHub repository. Okay, so now let me take you through that code, explain you what kind of things I have added, and in the end I'll show you the demo for that as well. Okay, so here is the code. Now I've written this code in a quite a different manner that you'll come to know while I go through each and every line. So first of all, necessary pin configurations defined here. Necessary MQTT parameters are defined here, like the Adafruit broker name. In my case, it is io.adafruit.com. The port, which is 1883. Then MQTT username and MQTT password. Now MQTT username is nothing but the username of Adafruit IO broker, and the MQTT password is nothing but the AIO key that provided by the Adafruit IO website. Okay. After that, here we need to provide the SOS number. So in this code as well, I have put the feature of pressing and holding the SOS button to send the SMS with the current location along with the phone call. Then after that, you need to provide the APN name because this will require the internet connectivity. So you need to provide the APN name. So do search for the APN name of your network provider and mention that here. Now the data sending interval you need to mention here, like what happens is this is a real-time location tracking device. So we need to define the time interval, like after how many seconds you want to send the next data. For my testing purpose, I'm sending the data after every 60 seconds. That means 1 minute. So you can decrease it, you can increase it based upon your application. Then we have the SOS time, which is mentioned as 5 seconds. Now this is the time interval of the button press. Okay, so in my case, I have written as if the button is pressed and hold for more than 5 seconds, then the SOS activity or SOS task will be triggered. You can change it according to your applications or necessity. Okay. Then necessary variables are declared here. Now here is the change in the code. So I have made the code based upon tasks. Okay, so this is a task based code in which I have divided or made 2 different tasks, one of which will be handling only MQTT based application or services, and second will be only responsible for SOS triggering and SOS activities. Okay, so MQTT task and SOS button task, 2 different tasks which will be running in parallel, so that we can be sure that whenever I press the button, it will definitely send the message and the call, even though the MQTT task is running in parallel. So it's a very stable code. We put a lot of time in building this code more and more stable. Okay, then the setup part is pretty much common. Now what change we did here is, first of all, we are resetting the board to make sure all the parameters are set to default state. Okay, again this time also we are using the same methodology of trying that AT command until and unless that command is successfully executed. Okay, so first of all resetting the board, then waiting for 20, let's just change it to 15 seconds. Okay, so waiting for 15 seconds till the A9G board initializes. Then after that what we are doing, first of all we are checking whether the A9G board is completely wake up or not. Then we are making sure the MQT is disconnected. After that turning on the GPS. Then these are the necessary condition for making the connection with the GSM network. Then we are establishing the MQT connection to the particular broker port, username, password that we have provided. Once it is connected, now here we are dividing the two tasks. All the tasks will be running in parallel. So that's why the void loop is completely empty. Okay. So moving on to the MQT task, what we are doing is we are getting the location by providing this command. And once we get the location, first of all, when we don't get the location, it will just print as no location data. And once we get the location, it will be publishing that location data to my MQT broker to this what we can say topic, which in my case is my username /feeds /GPS location /CSV. This is the topic name on which the data will be published. Then this time we are also publishing the real-time battery status, like how much percentage of battery left. It's a very important and crucial information that you should know about your tracker. So getting the battery information and sending it or publishing it to the topic called as Sachin SMS feeds battery. That's the two things that we are doing. Then we are waiting for 60 seconds. Let me just change it here. I will write it as send data after. So send data after into 1000. That means whatever time you provide into 1000, that much seconds it will wait. Now here we don't provide delay, rather we provide V task delay. That is mandatory. So we don't need to provide delay in this kind of task based codes. Rather we need to provide the V task delay. So what we have to do is it will definitely wait for 60 seconds. But in the meantime, it will be handling other tasks. It won't stop or hold that controller. It will be running all the tasks in parallel. That's the beauty of this kind of coding. Then we have the different task called as SOS button task, which will only be triggered when the SOS button is pressed, and it will check whether the button is pressed for more than the SOS time that we have mentioned. In my case it is 5 seconds, and if it is so, the SOS will trigger and it will call the function called as get Google Maps link, which will take the location data, create a Google Maps link and send it to the SOS number provided, and it will also make a call to that SOS number, and this will be really helpful in case of the emergency. So real-time location plus SOS button running in parallel, a fantastic code, and it is flawlessly working. Let me show you the demo. So right now select the right board and COM port, which is already selected, and let's just hit the upload button. Really, we put a lot of efforts in making the hardware and making the code. So well, do click the like button if you really appreciate our effort, and all this will be giving to you as well so that you can use it. Okay, so code is successfully uploaded. I'll open the serial monitor and let's just wait for a couple of seconds. So first of all, it is resetting the board as we have provided. Okay, it started executing all the commands. Okay, it also connected to the MQT broker, and right now we don't have any location data, but we do have the battery data, so it sent the battery data as 100%. Now it shows as delay, that means it is waiting for 60 seconds, but let's just check whether the battery data is received or not. So I'll go to my Adafruit.io dashboard, and here I'll go to feeds. And into battery, as you can see, I received the battery percentage 100 at the time 10:41, which is time in the clock right now. So we received the battery data over MQTT in real time. Now let's just wait for a couple of more seconds to get the location data as well. Okay, so this time it got the location data and it is sending the data, and the data is sent and the battery data is also sent. Let's just check the backend. And as you can see, we got the GPS data and battery data less than a minute ago. So right now we got the data. Now go to the dashboard and let's just observe in the map widget. So here is the map widget, and if I zoom it in, let's just zoom it out a bit. Okay, here is that dot. So let me just zoom into that dot, and it shows the location of my studio, and every 60 seconds, like every minute, the data will be updated on this dashboard, which is running over GSM network using our own made tracker 2.0. And now let's just test the SOS feature, whether it is running parallelly or not. Let me test it out. So I'll open the serial monitor. Okay, and now let's just press the button. Okay, it says button press 0, 1, 2, 3, 4, and SOS triggered. It got the location, it's sending the message. Let's just wait. And in the parallel, as you can see, it also published the data to MQTT. So both tasks are running in parallel. Wow, what an amazing code it is. So I got the data. I got the SMS saying that I'm here. I don't know if it is visible or not. So yeah, this is the link which I got. And I got a call as well. So this is the call which I got, and I can receive the call, and I can talk to it, and in parallel the data is being sent by that secondary task. So everything is running in parallel flawlessly without any interference in between. So that was the final code for our tracker 2.0. So those were the 3 super solid codes which you can download from our GitHub repository. Now, after watching all this, one obvious question must be coming in your mind, which is how long the battery lasts on this project. So well, to give you the answer for this, we put this device on testing mode. So we uploaded the real-time tracking code to send the data after every 60 seconds, and then we connected a 1000 mAh battery and started our testing at 11:12 PM, and the battery was 87% charged at that time, and we were successfully getting the data of both location and the battery. Now on the next day, when I came back to the studio at 11 AM, the dashboard shows that the last data was received 3 hours ago, and when I checked the logs, the data was last received at 7:57 AM. That means a 1000 mAh battery which was charged at 87% lasted for almost 9 hours with the data sending rate of every 60 seconds, or we can say 1 minute. Similarly, we also did testing for the second code, which was getting the location based upon sending SMS. So we were fetching the data of battery and the location every 15 minutes, and this firmware lasted for almost 12 hours on that same 1000 mAh battery. So that was the battery life, which definitely is not that awesome, but we can definitely increase it by changing the code a bit to make it more battery efficient. So now any one of you watching this video know how I can change the code to make it more battery efficient. Well, do share your suggestions, thoughts down in the comments of the video, and definitely try to modify that code and provide it to the community member. Now if I talk about how you can get one for yourself, then we are definitely selling this complete project through our website in both the variations with casing and without casing, whose link you can find in the description of this video. And today on 15th October, when I'm launching this video, it's my 28th birthday as well. So on this special occasion, I want to give back something to you. So if you purchase this product today till midnight according to Indian Standard Times, you will be getting flat 10% off on the product along with the techiesms merchandise with my signature on it. So this is kind of a return gift which I want to give to my subscribers on my 28th birthday. And if you're watching it from outside India and want to purchase this project, well, you can DM us on Instagram and WhatsApp and you can place the order from there. You can get those details in the description of this video. So that was the version 2 of our multi-purpose IoT tracker project, and I hope you all people really loved this project. And if it's so, well, do share your thoughts down in the comments of the video. Do let me know what's good in it or what's bad in it, and we'll try to modify and rectify that in the version 3 of the multi-purpose IoT tracker kit. So yeah, that being said, I am just ending this video here and now. Just wait for my next video and then explore, learn, share with me, techiesms.